Can I rewrite? Now, if I were to differentiate one more time with respect to t, I think I get the position function, which is equal to -1/2 gt squared plus v sub naught times t plus, another constant of integration. But if I think of the initial height as h sub naught, then when I plug, did I forget my t?
Yes.
Sorry, I said it, but I didn't write it. But if the initial height is h sub naught, that means when I plug theorem for t, the corresponding h value is h sub naught, but that just tells me k is h sub naught. Let me rewrite. So my position after t seconds is given by this expression. Well, maybe not that one, but this one. So now do you believe me? And if this is going to be a nifty little formula, I can always hold in my back pocket for the height of an object after t seconds, neglecting other things like air resistance. Then I'll come back over here and see what I can do. What did you guys say about the velocity when it reaches 90 feet? Let's talk velocity. Isn't that just ridiculous? You guys, I'm sorry. Can I rewrite this? Can I just plug in what g really is? I forgot what it was. It 32?
We're dealing with meters.
Is it 9.8?
Because it says in that question.
That's the point. I think in the question some quantity was given, I forget what, in terms of meters. Yeah. Well, actually the maximum height. So I think I'll choose a 9.8, if you guys don't mind. And I think when the rocket reaches 90 meters, then I think the velocity is equal to 0. Let's find out when it's going to reach that maximum height. So, my rocket reaches its max height. When you guys help me with this, when h prime t, I lost the number, it was 90 meters. It was 90 meters? Yeah. Is that okay? You'd be happy. Why are you squinting? Yeah, I think I'm 100% wrong. Because I think h prime of t represents velocity. I really want to find out how long it takes for the h prime of t to be 0, not the actual vertical height. Did you guys see that point? All right, I'll fix my clumsy mistake. There, I fixed it. Well, now when I plug theorem for h prime of t, I see that 0 is equal to this mess. Which means, of course, when I solve for t, I get this mess. Guys, I just lost myself. What did I just find? Make a full sentence in English. What did I just find?
Time.
The time it takes for me to...
For the velocity to equal 0.
Okay, for the velocity to be equal to 0. How about this in English? The amount of time it takes for me to reach the maximum height of 90 feet. Now, I know I failed to give you a specific time value. It's described in terms of v sub naught, but you have to confess. If I go back to the original position function, that one right there, and if I replace h with 90 feet, don't I get my negative 1/2? I took my glasses off. 9.8 t squared plus v sub naught times t is just that. I'm going to come in and replace the t with that particular quantity, v sub naught over 9.8. I want a yes or no answer. Is this an equation? What unknown? What unknown?
V sub naught.
The initial velocity. Oh, but shoot. The question was, how fast must a rocket be launched in order to achieve optimal viewing? In other words, if I solve this equation for v sub naught, I've answered the question. Is this an equation we can solve? Yes.
Yes.
Why? It's just one variable, and it's just quadratic, so who cares how nasty the solution might look? I can always solve a quadratic equation with a quadratic formula.
It's not even quadratic.
What do you mean it's not quadratic?
Well, I mean, you have 2 v naught squared, so you don't even need to use the quadratic formula.
Good point. I wasn't even looking at that. Technically speaking, it's still quadratic. You're just saying I don't have to use a quadratic.
Yeah.
I agree with you completely. Do you mind if I don't finish the math D portion? Okay.
Oh, I was wondering if you could explain some notation for me.
I can't wait. Before I do, you guys, I just messed up.
Okay.
There's a second part. Assuming the rocket is launched with the speed determined that I just found, how long after its launch will it reach its maximum height? How am I going to answer that second question?
Finding T naught and putting it back in the formula.
Yeah, done. Once I find V sub naught over here, put it, and this is going to be the time it takes me to reach the maximum height. So I apologize, I failed to answer that second question. So Brad, you said notation.
Yeah, I'm just a little. So when you find the second order derivative of dy over dt, why is it written like this?
You mean like this?
Yeah.
Like that?
Yes.
Okay, I got it. So you guys, let me jog your memory from your math B days. If I have a function I call f, think of it as a machine or a process, and I have an input, call it x. Would you guys not agree, no tricks, that the corresponding output is going to be nothing more than the input, affected or manipulated by f? And so if you guys don't mind me using this funky little math B notation, I think it's really illustrative, very illustrative to show you, the reader, that when it comes to f and f of x, they are not the same. F is the function of the process, f of x is the output when the input is x. If you think of f as a bread machine in my kitchen, on my countertop, f may be the bread machine, but when I stick in my flour, what's the corresponding output of the process? A loaf of bread. You guys see how the loaf of bread is different than the bread machine? And so I think when it comes to functional notation, don't confuse the process with the corresponding output. F and f of x are not the same. And so if it's the case that my function f is equal to x squared, you guys humor me. From the first step to the second, here's what the process does to inputs. If the inputs 2 or -7, the corresponding outputs are going to be or respectively. But what if I told you to consider a whole new process that maps x squared to 2x, or maybe it maps natural log of x to 1 over x? You can think of this process as what? The differentiation process. I can think of it as a function, kind of. I guess not. Functions map numbers to numbers. I'm now mapping functions. As an abstract algebraist, I sometimes refer to that as a functor. And so a functor you can think of as mapping functions to functions. So using the same notation, check this out. Do you guys not agree that f evaluated 2 is equal to positive 4? So over here, I think differentially operating on my x squared is what generates my 2x. Think of this as a differential operator. It's the little hammer dinging on the input to transform it to the output. Very much like my f notation. So if I already had this whole new function, which is derived for y, and I want to differentially operate on it, just for shorthand notation, I tend to rewrite this as, gosh, how can I say this in a non-hokey way? I guess I can't. Sounds hokey. When you look symbolically speaking, don't you see 2 of those? And upstairs, don't you see 2 of these? Oh, you're right. I guess I only saw a y once. And in that sense, I'm differentially operating twice on the y function in x. Hence the notation, Brad, is because I'm differentially operating on a pre-existing derivative.
Okay.
If you guys don't like my notation, don't worry about it. I'm going to change it this semester. Instead, we'll say, got a function y, let's differentially operate on it. Want to do it again? That's fine. You're just simply going to get this. This reminds you of math. What's your favorite math class?
D.
Yeah, math D. And so you and I are going to transform differentiation of the process into an extremely simplistic math D operation this semester. I'll just use slightly different notation.
So if I wrote that as like y double prime of x, would that be the
That's
same
fine.
thing?
This is y double prime of x.
Okay.
You can also write it as f double prime. You can also write this as differentiating twice on y with respect to x. I got a lot of different notation.
Okay.
What's interesting, Newton used none of this notation. Newton did this. And then a lot of engineers use the same notation today. It's just they only use that notation when it's understood that the independent variable is time t. So instead of Newton's notation, we use Leibniz notation for derivatives. You know the story between Leibniz and Newton, right?
Would you mind if we use Newton's notation?
I wouldn't mind. I understand. But just to realize that outside this math classroom is kind of out of context. We typically only do this if the independent variable is time t.
Did
Yeah.
I address that issue?
Oh yeah, it makes sense.
And so you still want to look at 7? I can't. Do you want me to go back somewhere? Verify that this thing right here is a solution to the differential equation 1.1.7. Maybe this is the one downside to this text. I know sometimes it's hard to just be jumping all over the place. It tends to do this.
I've lost it.
Oh,
It's
here
on
it is.
page 3.
Thank you, I just found it. Here's a differential equation. And by the way, that symbol in front of the y is a w, or excuse me, is an omega squared. It's just a constant. But my question is this.
So
Yes,
is y, is that the function
Yes.
of y, or is that just
When
the
you look at
variable
the
y?
TE, it's understood that the omega is a constant, but y is a function in t.
Okay, but I mean, what omega squared is being multiplied by?
Yes,
That's
it's
just-
understood to be scalar multiplication to the function.
Oh, okay.
Nothing
Okay.
more, nothing more fancy than that.
All right.
However, they want me to verify whether or not this thing right here. Hold it, I just lost it, darn it. Omega t minus b is a solution to that differential equation. So you guys, I'm being honest with you. Here's how lazy I'm going to be. I am simply going to take a peek at what the heck I have on the left-hand side of the equal sign here. I'm going to, with my algebra and calculus skills, massage it to see if I can clean it up to look just like that. And if I can succeed in doing that, then indeed this is a solution to this differential equation. Can you read it? It's supposed to be COS, cosine. So let's check it out. I think my very first term is differentiating once the first derivative function for 1 plus omega squared times 1. But jeepers, you guys, excuse me. This means I'm differentiating. Did I just write the wrong letter? Sorry. It's T, not an X. But that means I'm differentiating respect to T of let's put it in. Differentiate y with respect to t, doesn't that just simply give me an a omega times the cosine of omega t minus t? Oh shoot, I forgot my second term. Plus an omega squared times y, which has this alternative name. You guys, is my algebra and my calculus okay?
It's negative sign.
My apologies, you are correct and I'm incorrect. I didn't mean to make that mistake. Differentiate cosine gives me... Okay, so that was embarrassing. But let's do it again. Now differentiate the sine of anything, doesn't that give me the positive cosine of that thing? It's just that I've got this lingering coefficient on the outside, negative a omega, but differentiate the sine of all that garbage. Like I said, gives me the cosine of the garbage. Oh, the chain rule says I got to multiply by another factor of omega. Do you guys mind if I stop? Because now, trivially, these two terms are added to inverse each other. They clearly cancel each other out. I just have to generate a 0.
It's actually the other part of the question. I was a little,
The other part of the question?
yeah.
Oh, my apologies again. I still didn't read everything. Determine the constants A and phi in the particular case where these initial value conditions are being met, namely that, hold it, we need some room, just a minute. Namely that y is 0 is equal to a. And the derivative for y with respect to t when t is equal to 0 is equal to 0. In other words, find those two constants a and b, given those conditions. Well, you guys check this out. When it comes to this particular mathematical statement, let's rewrite it. And when I say rewrite, I simply mean take the original solution, plug 0 in for t, and simultaneously plug a in for the output. Doesn't it give me this? That little a is equal to, I have no idea what. Is that a cosine of negative v? But I think, in using this information, plugging it into the first derivative function, I never listed it, I'm sorry. Can I state it officially? I know we did it, but I'll write it. Y prime t is equal to my negative a omega sine of stuff. You guys tell me if I'm walking too fast. But now plugging 0 in for t and simultaneously 0 in for y prime, I think that generates this equation. Instead of 0 being equal to negative a omega the sine of phi, I'll change signs. Ah, shoot. Look what I've just done, you guys. I've generated two equations and two unknowns. I think we can solve for those unknowns. Are you there? Can anybody tell me what the solutions are? So over here, what can you say about little a? What's its value? It's wake up time. It's past noon. What can you say about the value for little a?
It depends on what phi is.
Yeah, I don't think we're supposed to answer the question. A was just given. I think the question is, we need to find values for uppercase A and phi itself, do you see my point? Okay, so I made a mistake. Let's fix it. Down here with the second equation, forget the first one. What's the second equation? I guess I can divide both sides by these constants. But that necessarily implies that phi is what angle?
0.
Yeah, I think so. So now when I take the original equation, plug 0 in phi, phi, I think it simply says that a is equal to uppercase A times the cosine of 0, but the cosine of 0 is equal to 1. It simply implies that big A is equal to little a. So I think I found my phi value, and I think I found my uppercase A value, given that lowercase a is a constant, and these two conditions are being met.
So what about omega?
Well, nobody gave me the information to find omega, because I'll be honest with you, omega is intimately related into the periodicity of the sinusoidal wave right here. And when you look at how somebody said, oh, the initial y value is a, and initially my derivative is equal to 0, it says nothing about the periodicity of the sinusoidal wave. So I think the information given doesn't even allow me to find a value for the omega. And besides that, Brad, nobody asked me to find a value for omega.
Okay.
Of course they didn't, because there's not enough information given. I'd have to then give some information about the frequency or periodicity. One's a reciprocal of the other.
Okay.
Everybody else happy? You felt really quiet. Okay. Can I get rid of